Today's topic is finite sequences. A sequence is a list of elements with a particular order. Arithmetic progression AP. A sequence of the form A, A plus D, A plus 2D, A plus 3D, A plus 4D and so on to A plus n minus naught D, A plus nd and so on is called an arithmetic progression or an arithmetic sequence. The sequence root 2 plus root 3, root 2 plus 2 root 3, root 2 plus 3 root 3 and so on. And 12, 9, 6, 3 are the arithmetic sequence with a common difference root 3 and 3. Root 3 and 3. Here minus 3 is common difference. 6 minus second minus first. T2 minus T1 is 9 minus 12. T2 minus T1 is common difference. Therefore, negative 3. Geometric progression GP. A sequence of the form A, AR square, AR power 3 and so on to AR power n minus 1 with A is not equal to 0, first term not equal to 0 and the common ratio is not equal to 0 is called the geometric progression. The sequence 1, 2, 4, 8, 16 and so on and root 2, 2 root 2, 4 are the geometric sequence. Arithmetico-geometric progression AGP. A sequence of the form A, A plus D, A plus D into R, A plus 2D into R square, A plus 3D into R power 3 and so on to A plus n D into R for n is called arithmetico-geometric progression. Harmonic progression next. A sequence H1, H2, H3 is said to be a harmonic progression if 1 by H1, 1 by H2, 1 by H3 and so on is an arithmetic sequence. The reciprocal of the series is harmonic progression. Let n be any positive integer. Let a1, a2, a3 and so on be n numbers. Then the number a1 plus a2 plus a3 plus and so on to plus an whole divided by number of terms n, therefore divided by n is called the arithmetic mean of the numbers a1, a2, a3 and so on to an. Geometric mean. Let n be any positive integer. Let a1, a2, a3 and so on to an be non-negative numbers. Then the numbers nth root of a1 into a2 into a3 and so on to an is called the geometric mean. Geometric mean of the numbers a1, a2, a3 and so on to an. Now ex number 5.2, sum number 1. Write the first 6 terms of the sequences whose nth term are given below and classify them as arithmetic progression, geometric progression, arithmetico-geometric progression, harmonic progression and none of them. First subdivision number 1 divided by 2 power n plus 1. Let us take an is equal to nth term is given, therefore an is equal to 1 divided by 2 power n plus 1. Put n is equal to 1, a1 is equal to 1 divided by 2 power 1 plus 1 is 1 divided by 2 power 2. Put n is equal to 2, a2 is equal to 1 divided by 2 to the power of 2 plus 1 is equal to 2 to the power of 3 is equal to 1 divided by 2 to the power of 3 plus 1 is equal to 1 divided by 2 to the power of 4. Put n is equal to 4, a4 is equal to 1 divided by 2 to the power of 4 plus 1 is 1 divided by 2 to the power of 5. Put n is equal to 5, a5 is equal to 1 divided by 2 to the power of 5 plus 1 is equal to 1 divided by 2 to the power of 6. Put n is equal to 6, a6 is equal to 1 divided by 2 to the power of 6 plus 1 is equal to 1 divided by 2 to the power of 7. Hence the first 6 terms are 1 by 2 square, 1 by 2 power 3, 1 by 2 power 4, 1 by 2 power 5, 1 by 2 power 6, 1 by 2 power 7. In this case 6 terms, 1 2 3 4 5, 2 to the power of 2 to the power of 2 3 4 5 6 and 7, 1 by 2 to the power of 7. Next solution number 2, let a and c equal to n plus 1 into n plus 2 divided by n plus 3 into n plus 4. Put n is equal to 1, first term a1 is equal to 1 plus 1 into 1 plus 2 divided by 1 plus 3 into 1 plus 4. 1 plus 3 is 4, 4 into 5 is 20. Here 1 plus 1 is 2, 1 plus 2 is 3, so 2 3s are 6. Put n is equal to 2, a2, put n is equal to 2. 2 plus 1 into 2 plus 2 divided by 2 plus 3 into 2 plus 4 is 12 divided by 30. Put n is equal to 3. A3 is equal to 3 plus 1 into 3 plus 2 divided by 3 plus 3 into 3 plus 4 is equal to 20 divided by 42. Put n is equal to 4. A4 is equal to 4 plus 1, 4 plus 2 divided by 4 plus 3, 4 plus 4. 30 divided by 56. Put n is equal to 5. A5 is equal to fifth term. A5 is equal to 5 plus 1 into 5 plus 2 divided by 5 plus 3 into 5 plus 4 is 42 divided by 72. Put n is equal to 6. A6 is equal to 6 plus 1 into 6 plus 2 whole divided by 6 plus 3 into 6 plus 4 is equal to 56 divided by 90. It is not an AP. It is not a GP. Also, it is not a harmonic. Write the first 6 terms of the sequence. First terms of the nth term, an is given below. An is equal to n plus 1 if n is odd. N is odd number, then you have to take nth term as n plus 1. N if n is even. Suppose you have to apply 2 4 6 8 even number, then take nth term as n. An is equal to let an is equal to n plus 1 if n is odd, n is even. Put n is equal to 1, take first 1 plus 1 is equal to 2. Put n is equal to 2, second nth term, n is equal to. Put n is equal to 3, 3 plus 1 is 4. Put n is equal to 4 in 4. Put n is equal to 5, a5, 5 plus 1 is 6. Put n is equal to 6 in even number 6. Hence, the first 6 terms are 2, 2, 4, 4, 6, 6. Question number 3, write the nth terms of the following sequence 2, 2, 4, 4, 6, 6. Nth term already known, therefore we have to take n is equal to n plus 1 if n is odd, n if n is even. Okay. Question number 2, 1 by 2, 2 by 3, 3 by 4, 4 by 5, 5 by 6. Nth term is a is equal to, first apply 1, 1 divided by 2. So 1 plus 1 is 2. So n divided by n plus 1. N divided by n plus 1. Substitute n is equal to 1. You get first term. 1 divided by 1 plus 1. Substitute here n is equal to 2. You get second term 2. Then third term. The product of the three increasing numbers in GP is 5832. If we add 6 to the second number, add second number and 9 to the third number, the resulting numbers form an AP. Find the numbers in GP. Let the three numbers in the GP be A by R, A, AR. Product of the three numbers equal to, already given, 5832. Take the product of the three numbers, A by R into A into AR is equal to 5832. Cancelling these two, or we get A power 3 is equal to 5832. 5832 means 18 power 3. 18 power 3 is equal to A power 3. The powers are equal, therefore the numbers are equal. Okay. Since 6 is added to the second number, 9 is added to the third number. Second number is A by R, A. So second number adding 6 we get A plus 6. Third number adding 9 we get AR plus 9. Now the sum of the three numbers, adding after sum of the three numbers is 24 is given. Therefore 18 by r plus 18 or plus 6 whole divided by 18 by r plus 18 or plus 9 whole divided by 2 is equal to 24. 24 is the middle term. Next, cross multiplying we get 48. Here 24, 48. So 18 by r plus 18 r plus 9 is equal to, now cross multiplying we get 18 plus 18 r square plus 9 r is equal to 48 r. 18 r square plus 9 minus 48. So 9 minus 48 is minus 39 r plus 18 is equal to 0. Divide out by 3 on both sides. We get 6 r square minus 13 r plus 6 is equal to 0. Now 6 r square minus 13 r. Minus 13 r can be written in the form of minus 9 r minus 4 r plus 6 is equal to 0. Now take first two terms common 3 r into 2 r minus 3. Take last two terms minus 2 is common, 2 r minus 3 is remaining part is equal to 0. Now these two brackets are same, therefore 2 r minus 3 into 3 r minus 2 is equal to 0. 2 r minus 3 is equal to 0, r is equal to 3 by 2. 3 r minus 2 is equal to 0, r is equal to 2 by 3. The GP numbers are a by r, a r. So apply a and r, we have 18 divided by 3 by 2. Then 18 into 3 by 2. So cancelling we get 12, 18, 27. Suppose we have to take the reversal order, a by r, apply we get 27, 18, 12. Okay, hence the three numbers are 12, 18 and 27. Sum number 5. Write the nth terms of the sequence 3 divided by 1 square 2 square, 5 divided by 2 square 2 power 3, no 2 power 2, 2 power 2, 3 power 2, 7 divided by 3 square 4 square has a difference of 2 terms. Let nth term of the sequence a n is equal to 2n plus 1 divided by n square into n plus 1 whole square. A n is equal to 2n plus 1 plus n square minus n square whole divided by n square into n plus 1 whole square. Add numerator, add n, subtract n square. Add n square, subtract n square, we get the given a n. Okay, add n square, subtract n square, then take 2n plus 1 and a positive n square, then remaining part minus n square. N square plus 2n plus 1 is n plus 1 whole square minus n square whole divided by n square into n plus 1 whole square. Now divide square. Then next term divided by denominator 1 divided by n plus 1 whole square. Sum number 7. If a, b, c are in GP and if a to the power of 1 by n is equal to b to the power of a to the power of 1 by x is equal to b to the power of 1 by y is equal to c to the power of 1 by z. Then prove that x, y, z are in arithmetic progression at a, b, c are in GP. GP means middle term is equal to square root of other two terms. Okay, squaring on both sides we get b square is equal to ac. Let a power 1 by x is equal to b power 1 by y is equal to c power 1 by y is equal to r. Each is equal to r is a constant number, so each is equal to r. Take first and last, we get a to the power of 1 by x is equal to r. Raising the power x on both sides, we get a power 1 by x whole to the power of x is equal to r power x. So x cancelled, we get a is equal to r power x. In the same way, b power 1 by y is equal to r. T power 1 by y is equal to whole to the power of y is equal to r power y. Raising the power y on both sides. Okay, y cancelled, we get b is equal to r power y. Take third and the last, c power 1 by z is equal to r. Raising the power z on both sides, we get a c 1 by z whole to the power of z is equal to r power z. Z cancel, we get c is equal to r power z. Substitute a, b, c in equation number 1. One is b square is equal to s. Apply, we get r power y whole square is equal to r power x into r power z. R power x, r power z can be written in the form of r power x plus a y. Now r power 2y is equal to r power x plus y. R are same, therefore the powers are equal. 2y is equal to x plus a z. Y is equal to divide root by 2 on both sides, we get y. X, y, z are in AP. The arithmetic mean of the numbers exceed means plus positive. They are add. The meaning of exceed is add. They are geometric mean by 10 and harmonic mean by 16. Add geometric mean by 10, harmonic mean by 16. Find the numbers. Let the two numbers be a and b. A and b. Let us take the two numbers be a and b to find a and b. Okay. Arithmetic mean a is equal to sum of the two numbers divided by 2. Geometric mean of the two numbers is equal to square root of ab. Harmonic mean of the numbers is equal to 2ab divided by a plus b. Now the question is, add geometric mean plus 10 is arithmetic mean. Add geometric mean by 10. Therefore geometric mean plus 10 is equal to arithmetic mean. A is equal to g plus 10. Number this is 1. Next, add harmonic mean by 16. So h plus 16 is equal to a. Equation number 1, equation number 2. Next, we know that g is equal to geometric mean is equal to square root of a into h. Squaring on both sides, we get g square is equal to ah. Number this is 3. From equation number 1 and 2. G plus 10 is equal to h plus 16. G is equal to h plus 16 minus 10. So g is equal to h plus 6. Equation number 4. From the equation number 1, 3 and 4, we have 6 plus 4 whole square is equal to 6 plus h. 6 plus h whole square is equal to h plus 16 into h. Multiply h in h plus 16, we get h square plus 16h. This side is 6 plus h whole square. A plus b whole square is a square plus b square plus 2ab. So 36 plus h square plus 12h. From the previous step, 16h minus 12h is equal to 36. So 4h is equal to 36, h is equal to 9. Substitute h is equal to 9 in equation number 2. We have a is equal to 9 plus 16. So a is equal to 25. We know that a plus b divided by 2 is equal to 25. A plus b is equal to cross multiplying, we get 50. But g is equal to 50. So the geometric mean g is equal to root of ab. Squaring on both sides, we get ab is equal to 15 square is 225. A into 50 minus a is equal to 225. 50a minus a square is equal to 225. A square minus 50a plus 225 is equal to 0. This is a secondary equation in a having two roots. How to find the answer? This minus 50a can be split into minus 40a minus 5a. Take first two terms, common a, remaining 40a minus 40. Take next two terms, 5 is common, into a minus 45 is equal to 0. These two brackets are same, therefore a minus 5, 45. Remaining part a minus 5. A minus 5 is equal to 0. A minus 45 is equal to 0 and a minus 5 is equal to 0. This means a minus 45 is equal to 0, a is equal to 45. A minus 5 is equal to 0, a is equal to 5. Substitute a is equal to 5 in equation number 5. We have b is equal to 45. The two numbers are a and b. A is 45. Question number 9. If the roots of the equation q minus r x square r minus p x plus p minus q is equal to 0. Now q minus r of x square plus add q, subtract q in this bracket. We give r minus p plus q minus q. Add q, subtract q. Of x plus p minus q is equal to 0. Q minus r of x square minus, take these two terms, q minus r, q minus r minus. So minus or minus positive, positive or minus q. So minus of q minus r plus p p minus q of x plus p minus q is equal to 0. Q minus r of x square minus q minus r of x. Multiply this x into this bracket. Next, p minus q of x. P minus q of x. Then plus last term. Here last but one term. P minus q is positive p minus q. Take q minus r of x square minus q minus r of x minus of p minus q of x minus p minus q is equal to 0. Take q minus r as common. Then here q minus r of x is common. Therefore x is remaining part, here minus 1. So x minus 1 plus p minus q is common of x minus 1. So x minus 1 is common, x minus 1 is common. Therefore q minus r of x minus p minus q is equal to 0. Here a, b is equal to 0 model. A is equal to 0 and b is equal to 0. X minus 1 is equal to 0 means x is equal to positive 1. Q minus r of x minus p minus q is equal to 0 means x is equal to p minus q divided by q minus r. Since the roots are equal, already given. Therefore 1 is equal to first root is equal to second root p minus q divided by q minus r. These two roots are equal means cross multiplying we get q minus r is equal to p minus q. Now this negative q comes to left hand side, we get q plus q pq. This minus r goes to right hand side, we get p plus a positive r. So 2q is equal to p plus r, q is equal to divide root by 2 on both sides, we get p plus r divided by 2. Hence p, q, r are in arithmetic progression AP. Today homework, EX number 5.2, sum number 1, subdivision number 3, 4, 5. Sum number 2, subdivision number 2 and 3. Sum number 6 and 10. These are the homework problems. Any doubt, reply the message. Thank you.